Welcome to this session. In this session, we'll familiarize ourselves with algorithm, flowcharts, and pseudocode. Each of them are representatives of the approach to solve a problem. They are not programs in themselves. First, we'll take up algorithm. What is an algorithm? It is an organized logical sequence of actions to be taken to solve a particular problem. So algorithm represent the approach to a solution, but not the solution itself. That means it is not a program. It is ready to be converted to a program, translated or transformed to a program in a particular programming language. This gives the approach. It is a step-by-step symbolic representation of approach to the solution of a problem. It gives approach to a solution of problem in a step-by-step manner. And it's a roadmap to converting the solution steps into a program. It's a systematic, structured, and a disciplined approach towards the solution for a problem. As we said, a step-by-step procedure is always systematic, and it is an organized form, a structured form. And since we are approaching step by step, we call it as a disciplined approach towards a program, towards finding the solution for a problem. Right? A combination of English words and a limited set of mathematical logical relationship operators are used to develop the algorithms. Now, what is a solution for a problem? That depends on the problem. If the problem requires arithmetic operations, then arithmetic symbol should be there. If the problem requires comparison or establishing relationship between the various data items that participate in this solution approach, then relational operators are required. Similarly, if it is based on certain logic and evaluation, logical operators are required. Is this enough? We need certain English words also, limited set of English words also. Suppose I want to declare a variable, that variable should have a name. I should operate on that variable. So English is also required. And a structure is developed. We'll see an illustration here. Here we take a simple problem to start with. What is the problem we have here? Write an algorithm for printing larger of two numbers. Now you see there are two tasks to perform. First one is larger, printing larger of the number. That means the operation to be performed is comparison. So relational operators are required here. An operator that can compare whether one number is greater than the other or not. We need not check both the numbers. If one is checked, the second one need not be checked at all. For example, if number 1 is greater than number 2, then there is no necessity for comparing whether number 2 is greater than number 1. It is already inferred if the first statement is false. So we use a conditional operation in this algorithm. The second one is print the output. So what can be printed? It could be either A or B. So print statement should come twice in our algorithm. Once if A is greater than B. Second one, if B is greater than A. We'll see that. Every algorithm has a first statement as start or begin. Either of them can be used. If start is being used, the last statement would be stop. If begin is used, the last statement will be end. It's that way. It goes as a pair. So first task to be done is input the numbers A and B. Where are the input from? That depends on the programmer, whether they are in the part of the program or they are to be given on the keyboard at runtime. Just we simply write input A and B. And there is one more variable required. No, not required in this program. Okay, this is next. If A greater than or equal to B, then look to the structure, that is structure of this statement here. If is a condition that is used, that means the relational operator is to be preceded by the if. If is a limited keyword, English keyword, that is. If is always succeeded by then. In between if and then, there will be the expression to be evaluated. That's how it is written. So if A greater than or equal to B, then look at the symbol greater than or equal to. Normally in mathematics, we write greater than. Below that left traversing line, we write equal to symbol. But in algorithms, we don't use it. We write it this way only. Right? Of course, we can write greater than or equal to in the way we write in mathematics, since this is happening to be on with the pen and paper only, on paper only. But in computer, it is not possible to use that symbol. That symbol is not there, and it does not have, even if it is there, it is a very special symbol which does not have any operational value in the language. So this is the way we write. We habituate ourselves using some program related symbols also in the algorithms here. Next. So if it is true, so if condition always evaluates to true or false. If it is true, print A. Then else. So if then else is a pair. If then is one pair. If there is second statement to be done after the if condition fails, then we use else. Otherwise, we don't use it. It's purely dependent on the nature of the output we are taking, how we are taking it. Right. So print B. Is it over? There is one last statement to be written. What is that? Yes, stop. Right? This is how algorithm is written. In the next slide, we have again some exercises here. Right? See, adding two numbers, multiplying two numbers, these are for your practice purposes. Now repeat the problem for following cases. What does it say? One of the numbers is negative. Both numbers are negative. In a programming language, you need not worry whether it is a negative or positive. The programming language construct will take care of subtracting or adding. But from algorithm point of view, we need to know. For A, I am going to solve next by checking whether greater or lesser, which one is negative. See, A could be negative or B could be negative. What does this say here? If one of the numbers is negative, so I will take both A and B to be negative in one step each. Then I'll come with an algorithm. We'll do that. I'll do this job on the whiteboard that we have facility. I'll show you how to do that. Just a moment. While it loads, we will see here. It's taking a while. Just hold your patience. In a moment, the whiteboard will be available for us. Fine. Shows whiteboard will not be recorded. Chalo. Here I am typing. As usual, start is the first statement. Of course, we'll number them. It's a good habit. Second statement is input, or we can use capital letters also. Purely our convention. Input A, comma, B. I need one more variable here because I am performing addition operation, unlike the other algorithm. C will store the result of it. Now what should I do? Statement 3. If, how do I check whether it is negative or not? By looking at whether it is less than 0. If A less than or equal to need not equal to. If a less than 0, then 4, I'll move just inside. C is equal to see how I have written is equal to here arrow and two symbols. C is equal to B minus A. Then fifth statement, else. I have to check again. Sixth statement, I have to check whether B is less than 0. If B less than 0, then if B less than 0, then again I move inside to indicate that this is nested here. Take the number 7. C is equal to, as usual, not equal to symbol, right? C is equal to A minus B. Then what is the step left for me? Print C. Is it all? Technically speaking, that's all for the problem, because we are checking. The problem says if one of them is negative, then go by it. If not case, then there is another possibility also, printing sum of the two numbers. That part will not, we know already about it, right? So the last step is stop. That's the end of the part here. We have completed this algorithm here. Now, okay, we'll come back to our presentation now. So this is how we develop algorithms. As we proceed, there is no point in spending whole lot of time on whole lot of problems go on developing. As we do solve problems in subsequent classes, there we develop algorithms, more complex algorithms also, right? Before I go to another topic, let me take another algorithm for finding the sum of n natural numbers. Again, we'll go back to the whiteboard here. In the whiteboard, we'll write. So we'll take a problem of solving or finding sum of first 100 natural numbers. Now you see, what is the logic here? 100 numbers are given to me. I have to find a solution. There are two approaches to this problem. Mathematics point of view, we have learned a formula. We know problem for sum of n natural numbers, right? I'll erase this one. Take the new one, right? So there are two approaches. Take the formula n into n plus 1 by 2. Find the solution. But what I will do here is, I will develop a basic and primitive algorithm where each number is taken one at a time, added to a particular variable called sum, which stores the sum actually in each step. How many times should I do that? 100 times. So I require a loop control variable which serves two purposes. First, it controls the loop one by one, giving number to me, and the second one, the number is added to the sum. Second one is sum, a variable that stores the sum of the numbers, partial sums. At the end of the loop, it will be giving the total result. We'll start. First step, as usual, start. Second step, input. Count, we call it as count. Variables we write in small letter. We'll call it count, right? Count, and I will initialize sum to be 0. See, I have written both of them on the same line. That should not be a problem. Okay. Next, third step. Here, I am using a construct, loop construct. Exactly 100 times is there. So I am using for loop here. Why did I use for loop only? We'll discuss when we go to C programming language. Here we are getting just exposed to how a solution can be developed. For is a keyword we're using lowercase letter. For count assigned to 1. That means count is assigned 1. From 1 to 100 I want, right? For count assigned to 1, count is equal to 1, comma, count less than or equal to 100, comma, step 1. What is the meaning of this one? I want to start the count from 1. I would like to do it for 100 times. And step 1 here is increment the count 1 by 1. So this loop will take. In the loop, what should I do now? Sum should be and new value. Sum should be updated with previous value of sum plus. So previous value of sum is initialized to 0. Now what is the value of count? 1. Okay. And this count is added. How many times does it happen? Since we have written in a loop here, it happens. As usual, we'll take this sum into inner side a little bit. Inner side. To mean to say that this is a part of for loop. And then once, how many times does this loop run? It runs for 100 times. How does it run? Because we have put in a for loop here, increment by step by 1. If we want by steps 2, then I can write step 2. Then 1, 3, 5, sum of odd numbers will come, right? So 5. And sixth step. Stop. This is how we develop the program. A recap. How we have done? Start. There are 2 variables that are required. One for counting purposes and giving each number for some purposes. And the partial sum is stored in a variable called sum, which is initialized to 0. Right? If it is not initialized to 0, here nothing happens. In this algorithm, nothing happens. Even if you don't initialize it to 0, nothing happens. But when it comes to programming language, if we do not initialize, the memory allocated would have some other value there, and the value given by us in each round gets added to that number, we'll get junk answer. So we should take care that in the programming languages, when we are performing sum or product, sum variable is initialized to 0, product variable is initialized to 1. Okay, this is how we develop algorithms. Now we'll go to the slides and go to the next point that we have to discuss. Okay, as we said, there are certain symbols that we use. We can see here what is the purpose of these symbols. We'll see. It's a graphical or pictorial flowcharts. Sorry, we are going to the next topic. Flowcharts, right? A flowchart is a graphical or pictorial representation of an algorithm or part of it. Now, algorithm uses partial English, partial symbolic representation, and mathematical operations. A flowchart is a picture equivalent of that one. It shows pictorially the order of flow, structure of flow. So it is a diagram. We have symbols here. I will come to these symbols in a while. The diagram is drawn in a stepwise manner in the exact order of the way humans solve the problem. So first what, next what, next what. This is what we do here. Same as algorithm, but the only difference is we have picture here. It is popularly said that picture speaks 100 words. By looking at the picture, it will be very easy to follow rather than, algorithm is, it doesn't mean that algorithm is difficult, but flowcharts are easy to follow. It also represents the approach to the solution like algorithm and uses mathematical shapes and some special symbols to represent the sequences. Each symbol is used to represent a specific task. That means one block, one image or one shape cannot be used to do something else. There is fixing. And it is a representation of a problem but has to be converted to a program for execution. Same as algorithm. It does not solve the problem, it shows approach to solve a problem. Now, what are the symbols used in flowcharts? As you can see here, this is oval symbol, start and stop. Parallelogram is for input and output. A rectangle is used for showing some computation takes place or processing takes place. Now what we said is that whenever inputs are to be taken or printout or output is to be given, only parallelogram used. Rectangle cannot be used there. Rectangle represents the processing. When we are processing the data, we use rectangle. When we are inputting, we use only parallelogram. Similarly, diamond symbol is used for representing decision making, like if condition. A circle is used for connecting. Say I am writing flowchart on paper and pen. There is, at the end of the paper, there is no place again, right? So what it is, for huge problems, more complex problems, real-time problems, the flowcharts run into several pages. So how do I know which part connects to which part in the flowchart? I use circle. So I terminate the last part with a circle and then use an arrow symbol to control. And to this circle, I give label. Say my flowchart has 5 parts to it, running to 5 pages. On the first page, right, what I do is the last symbol that I make is circle and write A. A goes to, and in the next page where I take the first symbol that starts is circle with A, which means that this A connects to that Alternatively said, if I had infinite size of paper, I would have done vertically to show the flow chart in the same flow, single flow. Since it is not possible to have infinite length of page, then we cut into pieces and links. These are links. A circle is a link connector. Arrows are used to show the flow of the diagram, flow of the solution approach. Now again, we'll take example of a flowchart here. Fine. Develop a flowchart to divide two numbers and print the result. So what is the first step here? It starts. So first step that I take is start the program. Then an arrow should come which tells what to do next. What to do next? Since it is division of two numbers, I need to take input. So input is given in parallelogram. So parallelogram, read mulc, mulp. I have used cryptic words here. Mulc means multiplicand. Mulp means multiplier. So naming convention should be small enough to understand what variable it, what value it represents, or what is the operation performed by it, what is the purpose served by it, but not long enough. In typing, it takes a lot of time. We may commit mistakes also in typing, right? That leads to another kind of problem altogether, right? And the quotient and the remainder are initiated to 0. See the arrow, how it is written. I have not used the equal to symbol here. It should be quotient is equal to 0, remainder is equal to 0. But I have put the symbol here. In equal to is in several programming languages, most of the programming language, equal to is the assignment operator. But it is not so in some programming language. So what we do here is we use platform independent, program independent symbol for assignment also, and this is the arrow that is used for representation. So we have taken input. Then what should we do? Division operation, flow again. So quotient is equal to AIB, A divided by B. Quotient I get when I divide A with B. How about the remainder? A minus B times of the quotient that I take. I have already taken quotient, and so what exactly is remainder? From A, whatever is the maximum number goes, maximum value that goes, that is taken, and there is subtract, and what is left over is remainder. So the same thing we have done here. remainder is equal to A minus B into quotient. If A is exactly divisible by B, quotient will be, remainder will be 0, quotient will be an integer. Print quote and remainder, arrow and stop. As simple as that. Fine. We'll see. Next, I have given some assignments here also. Same problems, right? And again, here, sum of first natural numbers. Now we will solve this one in flowchart. How would it look? How do we show the repetition in a flowchart? Again, we'll go to whiteboard and try to get the flowchart there. We don't want this box now, we'll need pen. So finally taken pen. So the first step is start. First step is start in a symbol, then follow, then rectangle, sorry, parallelogram. And what should be in this parallelogram? This is a program to find the sum of n natural numbers. So I need 100 natural numbers, not n, 100 natural numbers. So 100 is fixed here. So I require sum initialized to 0. And then count for counting up to 100. Then arrow. So first what I do is take the condition. What is the condition? Is count equal to 100? Because I have to take first 100 numbers. Is count equal to 100? Then there are two solutions possible. One is yes, again an arrow. The second one is no. That is count is not at 100. If it is 100, then what should I do? I have completed the processing, or I have completed the processing of, sorry, I have not completed processing yet. Yeah, we'll go with no. We'll go with no and then come to yes here, right? So what should I do? I have to process it. What is the processing here? Performing summation, right? Sum is equal to sum plus count. I have it. Now what should I, is it over? Count is to be incremented. So here I count is equal to count plus 1. Now where should the control go? It should again count, check the count variable for 100. I have written count here, C here, for the both are same. So what should I do? I take the arrow, come back to this point, count, check whether count is equal to 100 or not. I repeat, start, sum is initialized to 0, count is taken, is count is equal to 100, or here also count we can initialize to 1. Is count is equal to 100, 1 equal to 100? No. When it is no, I come to updation. Sum should be updated with whatever is sum value, previous value, and count. What is the significance of this one is that sum is updated inch by inch, step by step with a new value. Partial summing is done step by step. Again, Do not forget to increment C value. If you don't do that, it is not going to happen. You will be writing wrong program also. Your program will not give output. So count is incremented. Again, count is to be checked with whether it is right or wrong. I mean, whether it is 100 or not. If not, so this loop goes on. This is how we show the loops, right? And lastly, when it goes to 100, then the condition is broken here. The condition is broken here. So what should I do now? Print sum and then stop. Algorithm is over. Flowchart is over. This is a we rate. We'll take more complex flowcharts as we go through the subject in programming, right? Get familiarization with the skill or art of developing programs. Now we'll go to the next topic, a pseudocode, the third part of it. In fact, the starting point for any solution for any program is pseudocode only. What is a pseudocode? A pseudocode is a methodology that represents the approach of a programmer of implementation of a program. Pseudo means false. It is a code, but it is not a code to be implemented in a programming language. So we call it as pseudo, a false code, right? How is this developed? It is used, it is independent of any representation. It is purely like flowchart. Flowchart, there is certain standard. Algorithm, there is certain standard. Pseudocode does not have any standard. It is purely the prerogative or the domain of the programmer or developer. You write in your own language, in your own style, known to you only. So it includes small cryptic English like words to write the pseudocode. Here I have used the word algorithm, no issues. These words are called mnemonics. It has no particular syntax. It uses annotations. It is purely, it cannot be directly compiled or interpreted like other symbolic representation. What are the advantages of this one? Improves readability of the algorithm. Since you are writing scribbling on pen and paper, you take the steps first of all. Then you represent it a flow chart. Right? It's a bridge between algorithm flowchart and programming language. Before going to flowchart, we develop pseudocode. Pseudocode is converted into flowchart or algorithm, and then maybe sometimes all the three are needed. It gives clarity to the programmer about the exact task performed by each step, each statement. How does it differ from algorithm and flowchart? As I said, algorithm and flowchart have certain standards. They are used in a similar fashion throughout the world. But pseudocode is purely user's domain or developer's domain. He can have his own way of writing the pseudocode. We'll take an example again. The same problem I have taken for establishing or demonstrating the ease with which we can do the work, or moving from pseudocode to algorithm is much easier. To demonstrate that, I have taken again printing large of two numbers. I have taken the algorithm from there. We'll see how. So the first step, what is here is, again, we'll develop the solution here. Again, we'll go with sharing the board. On whiteboard, we will do it. I'll take the notepad again, since it is English-like. Pseudocode, my own. So let me erase all this. Fine. I'll take note here. I need not number also because it is my way of writing, right? Start the solution. First step. Read input values for A and B. Task is to compare these two numbers. Check if A is greater than B. So print A as the answer, else if not print B as the answer to the, it's more like English only, or I am writing, I have written this way, you can write in another fashion. So this is how it writes. So first step is start. So end the task. Okay, this is how we do it. So again, an assignment I am giving you, you develop the pseudocode for all the problems that you have done. We'll stop here. In the next session, we'll jump into C programming language, see these features of C programming language, and start writing small programs in C.